Now, a catalyst, we can define it as a substance that alters the rate of a chemical reaction but remains unchanged at the end of the reaction, meaning the catalyst will not actively participate in a chemical reaction. Now, today we are going to use zinc granules. I'm having the same quantity of zinc granules, and what I'm going to do, I'm going to add the same volume of hydrochloric acid. I'm going to add 10 ml here. Yes, add 10 ml. Then I also add 10 ml. Now, we very well know that every time I add zinc granules to dilute hydrochloric acid, I'm expected to get bubbles of hydrogen gas. As we can see here, if I zoom, you can see that there are bubbles that are being produced, that is for hydrogen gas. But we see that the way they are being formed, we can see that it's almost the same, and maybe it's not quite amazing, but now we are going to see what will happen if I add something called a catalyst. Now, a catalyst can be a solid, it can be a solution, but remember, catalysts are always specific, meaning a catalyst will catalyze reaction A, it cannot catalyze reaction B. Now here, the catalyst for this reaction, it is always dilute copper to sulfate solution. And when I add some few drops, because we know catalysts work in small or in minute quantities, and it may alter the rate of this chemical reaction. Now let's see, if I choose randomly, because here I'm having the same quantity of zinc granules, same quantity of hydrochloric acid, now I'm going to value 1, I add there a catalyst. So I can check so that I can mix my catalyst very well, and we can see and we can compare what this copper to sulfate solution has done to this reaction. Because if we try to look at the rate at which bubbles are being produced here and the rate at which bubbles are produced in this reaction where there is a catalyst, we can see that indeed the catalyst here, it has increased the rate at which bubbles are being formed.